Hello everyone and welcome to Algebra 2. This is actually just an extra video on different topics. The first one is going to be from section 7.2, which is an alternative graphing method. So if I wanted to know how to graph this, the way I explained it back in the section 7.2 video was I would figure out first what x can't be, because you can never have the denominator be 0. So I know that x can't be -1, which means at -1 there is a vertical asymptote. And then to find the horizontal asymptote, you can just look at the two coefficients of the linear terms. So 2 divided by 1 is 2. Now I know that that's where my horizontal asymptote is. And then as soon as I plot a couple points, I can make the branches and I'll be done. So I usually set the numerator equal to 0, which is going to give me my x-intercept. So x is equal to -3/2 or -1.5, which will be right there. And from that one point, I can get that entire branch. And now I need something over here. So usually I try the y-intercept. And when I plug a 0 in for x, I get 3/1. 1, 2, 3. So just using the x and y intercepts, I can make a great graph. But there is an alternative method that your book uses, so I'm going to show it to you, and that is using long division. See, some of you already don't like it, right? So x plus 1 can be divided into 2x plus 3. So I'm going to multiply by 2. That gives me 2x plus 2. Don't forget to subtract, change the sign, which gives me 1. So now I can rewrite this and say that 2x plus 3 over x plus 1 is the same as 2, that was the entire answer, and then the remainder plus 1 over x plus 1. Now, at first you might be thinking, how did that help you? Well, let me rewrite it backwards and as a function, and maybe you'll see it. Now, do you see it? This is a basic hyperbolic function, which means you could just do easy points for y is equal to 1 over x. So you have 1, 1, 2, 1/2, -1, -1, -2, -1/2. Nice, easy points. And all you have to do is move it to the left 1 and up 2, which is how you do so many of your other graphs. So that's what ours is, up 2 and left 1. I personally would rather not do the long division and make a table, even if my function is simple, and then shift. I really like the blue method, but I want you to see it in case you just really love this concept of always moving left and moving up or down, getting your new origin, and then plotting basic points. So that's going to be up to you. However, we're not actually going to graph all these. You can practice your graphing if you want to. All we're going to do is practice getting it into that other form. So I'm going to do the long division. X plus 1 goes into 3x plus 5. So I multiply by 3, and I get 3x plus 3. I'm going to use a different pen color to make sure that I subtract. And that gives me 2, and that's it. So the remainder is 2 over x plus 1. But to rewrite this, I'm actually going to write the remainder first, and then write plus 3, which is a little backwards, but it puts it in the form that is good for somebody to see, oh, this has just been moved up 3 and again to the left 1. So you could get your asymptotes that way. And then when you made your table, though, you just have to remember to use 2 over x. 2 over x. Like, don't use the 1 and the 3. So if x is 1, you would get 2. If x was 2, you would get 1. And you could plot those points from your new origin. So 1, 2 would be 1, 2. It would be up there. Okay. So up to you. And of course, you also can use synthetic. So instead of doing the long division if you can remember it, you can put the positive 3 there. Do you remember you have to put the opposite? And then do 7 and 4. It's a very short synthetic. So when you bring down the 7, and then 3 times 7 is 21, and then I get 25. But you have to remember what this means. This is the answer, and this is the remainder. So we have 7 plus a remainder of 25 over x minus 3. This is a good example of when this is definitely not easier to graph. You're moving it up 7 and to the right 3, but you have to deal with that 25 when you make your table, which could be really challenging. So not my choice, but something that I wanted to make you aware of. All right, you should be trying number 4 on your own. I'm going to do it one more time by synthetic. So I put a 2, not a negative 2 in the box, a 4, and a negative 11. And then I bring down the 4, I multiply to get 8, negative 3. Remember, this is the answer and this is the remainder. So we get 4 minus 3 over x minus 2, which is the answer to the division problem, but to rewrite it as a function, it's really much better this way so people can think about the shift that's happening here. All right, there's another alternative method if you want to use it. So this next little topic is inverses, which we really didn't do in any section. They're a little bit tricky because let's draw this parent graph for y is equal to 1 over x. So x can't be 0, and its asymptote, its horizontal asymptote is also 0. And if you do 1, you get 1. If you do 2, you get 1/2. It looks like this. If you do negative 1, you get negative 1, negative 2, negative 1/2. It looks like this. But let's do the inverse. So to do the inverse, I switch the x and the y, and then I solve for y. So I'm going to have to clear the fraction. And now I have xy is equal to 1, and then I get y all by itself. I'm right back where I started. And if you think about it, the inverse should be symmetric around the line y is equal to x. But this graph is already symmetric around the line y is equal to x. So its inverse is itself. So just a tricky little concept there, which is the main reason we didn't talk about inverses. Of course, if I shift it left, right, up, or down, it is going to have a different inverse. But just an interesting thing. So let's try and find the inverse of these. So remember, step 1 is always to switch x and y. So I get x is equal to 2 over y plus 3. Step 2 is to solve for y. Me personally, I always clear the fractions. So I get x times y plus 3 is equal to 2. So I've cleared the fractions by multiplying both sides by y plus 3. That gives me xy plus 3x is equal to 2. Xy is equal to 2 minus 3x. And then I divide both sides by x. So I'm going to not use the term y anymore because I want to show that I have found the inverse. So 2 minus 3x over x. The question is the inverse a function? So that means, does it pass the vertical line test? Now, without actually graphing this, I do know that it has a horizontal or a vertical asymptote at 0, right there. And negative 3 over 1 at negative 3, it has a horizontal. And it's going to have branches somewhere, but those branches will not overlap. So yes, it is a function. This is definitely the inverse either way. The question is just, is the inverse a function? All right, that's it. You might want to try the next two on your own and see if you can get it. So this is y. So step one is to switch x and y. So I get x is equal to 1 over y minus 2. Now I need to get the y all by itself. So I think I'm going to add 2 first. There's lots of ways to do it. And then I'm going to multiply both sides by y. You have to clear that fraction. And I get y times x plus 2 is equal to 1. Y is equal to 1 over x plus 2. Now, a lot of times I clear fractions in the beginning. So that would, if I multiplied both sides by y first, I would get xy is equal to 1 minus 2y. And this is where some people get confused because now they have two y's and they don't know what to do with them. But you would put them on the same side, and then you would factor it out. This is a skill we'll need a lot in the future, so I don't mind showing it to you now, even though it's a little harder. But notice you get the same answer either way. But this concept here, what it happened was it created two y's, and sometimes people get really stuck there. So in this case, clearing the fraction on the second step is a little bit easier. Number 3. Okay, so now we have an x to the 4th. This is not from our normal section. This is going to create something completely different. So I go ahead and I switch my x and my y. X is equal to 1 over y to the 4th minus 7. I am going to add 7 first. 1 over y to the 4th. Now I'm going to clear my fraction. Y to the 4th. And I get y to the 4th times x plus 7 is equal to 1. And that's 1 over x plus 7. But now I have to do the 4th root. So 4th root of both sides, 1 over x plus 7. So f inverse is the 4th root of 1 over x plus 7. Okay, a little bit different there.